Hi all, I welcome you to the Building Culture podcast where I invite incredibly smart people who build things. Whether they be engineers, entrepreneurs, programmers, hobbyists, or researchers, it does not matter. As long as you're someone who's passionate about building things, I'll find you and podcast you. Hi, all. I want to take a brief moment to thank you all personally for supporting this podcast on YouTube and on all major podcast platforms, including Google Podcasts and Spotify. The podcast mainly features interesting people in robotics, artificial intelligence, and entrepreneurship. If you believe that the information that I'm providing might be of benefit to you or to someone you know, it would be really great if you could hit the subscribe button and press the notification icon so that you can get notified on time whenever the next part is out. It would literally take you a second or two to subscribe to the podcast, but it would really mean a lot to me because I can grow the podcast to a level where I can reach more people, invite ever more interesting guests, and have a more meaningful impact. So let's begin now.
Yeah. Um, okay. So now let's talk about learning robotics for beginners, right? So you have been self-teaching yourself since the beginning, and of course you took a lot of courses at the university when you did your master's thesis and all, and you worked on projects, and then you worked on MathWorks. But at the same time, there's a component of self-learning involved, right, in all of these stages. And I'm sure you are also always self-teaching yourself because you're also putting educational content online. So, what is the best way to start learning robotics? And I think the next part would be uh, how do you continuously keep learning with robotics, because you have to catch up with the research that is
Yeah.
constantly, improving.
Yeah. Whew. Okay, there's a lot there. I think the first thing I could say about that is that we are now in a world where it's so easy to just passively absorb information. So I will very outright warn people to not just watch a bunch of YouTube videos and call it a day and say that you know something. So no passive learning. However, YouTube videos do have their merit, and this is how I use them.
Mhm.
I I think that just watching, and by YouTube videos I mean things like watching a lecture or watching like a lecture, a guest presentation at a university. All of these things are available on YouTube now. It's great. Or like keynote speeches from conferences, that kind of stuff. I actually think that's a really good starting point in understanding the layout of the field, particularly for something like robotics, because there's just so much terminology, so much like jargon that whenever I'm learning a new field, like for example, when I was teaching myself natural language processing, I just
Mhm.
watched I spent a week watching just videos on how people talk about it. Like what are all the terms that they use, like tokenization or like, or even what are the papers that people are referencing, like, transformer this, transformer that, nowadays. So just basically watching videos just to see how people are talking about the problems, what the state of the art is focused on, who are the key people in the field. I think it's a good starting point so that you become kind of conversational in that area. You don't yet know how to
Mm.
do things, but you know the purpose of things. Um, and another example could be like if you're trying to teach yourself computer vision, maybe you'll watch a couple of videos to understand like what is image recognition versus classification, versus object detection versus segmentation. Like you kind of know what they're for. You don't know any of the math or implementation. That's fine.
Okay.
But you now know the types of problems, the types of solutions that exist, and that's a starting point. Then you immediately want to move on to actually doing stuff. That I don't know. I can't think of a better
Yeah.
way as a better alternative. But yeah, I think actually having hands-on uh, experience is the way to go.
Mm.
And that can be difficult depending on how you're learning things, right? You know, if you're very self-motivated, then maybe you can just open up, like download a software package and just start like typing stuff up, or get out a
Yeah.
pen and paper and start deriving things. Those are all good things. And if you can learn that way, then that's awesome. But the best way to learn something is to have a project or a problem in mind. It's very different saying, I'm going to teach myself TensorFlow, so I'm going to open up a tutorial
Yeah.
and just like run it and like, change a hyperparameter, run it again, be like, oh, that's cool. Learning rate helps. Versus saying, I have a data set, I need to solve this problem. I need to classify something. What do I do? You learn a lot because now you're not like just following along a carefully crafted tutorial. You're actually just going to run into a lot of problems that you have to solve along the way. Like,
Yeah.
oh, maybe this network architecture doesn't work for me. Maybe TensorFlow was not the right tool because, whatever reason, maybe I have to do something else.
Yeah.
So
So
yeah,
again, this is pointing to like switching from a tools focus to a project focus actually. So with the
absolutely.
tool you could learn everything about TensorFlow and maybe use, let's say, 5% of it in a project or something. And
Yeah,
but you said that it's a good idea to have a general overview to get to know the terminology that is used in the field, let's say computer vision or NLP or whatever,
yeah,
and then immediately start working on the project, right?
right.
So yeah, and then you learn things along the way.
Yeah,
Yeah, because
yeah.
that
So
is the thing, right? With there's so much information available online, and it's like, yeah, you could watch an hour of a YouTube video, and you could say, I learned about, let's say, humanoid robotics or whatever.
yeah. Yeah, so I would warn people from credential chasing in that aspect. I was guilty of this at some point in my life too, where I would just sign up for all these online courses and be like, oh, I got a certificate from this course because I answered
Yeah.
4 multiple choice quizzes versus, I actually did a project and here's my GitHub profile.
Hmm.
Very different things. One thing that really, really bothers me seeing on LinkedIn is when people post a certificate that they watched a webinar. That like
Oh,
hurts my
is
soul.
that a thing?
It hurts my soul so much. So,
Okay.
so please don't do that. Do things. Um, learn things, write about them, write some code, play around with it, solve a problem, and the learning will just come.
Yeah. That's an interesting view. So I want to talk more about your view on MOOCs and the online courses and stuff. But before that, let's cover the part where yeah. So one of the things is you have to be constantly learning if you're even involved in AI, whether in industry or academia, whatever. You have to be constantly catching up with the research. So how do you suggest one does that?
Ooh, yeah. It can be intimidating. I think I don't I don't have like a one size fits all answer, and I think I've just learned to like resign myself that I'm not gonna know everything. The most important thing is to rely on other people. They're like, if you have teammates that are like really good at other things, maybe it's just something where like they're just always going to be the person that you lean on for that particular area of expertise, and maybe they're reading a lot of literature. Let's say let's say you're a controls person and they're a computer vision person. You can always have conversations with them like, hey, what's the latest thing in the field? Like, what are you working on? That can be, from like a grad student, this is my colleague, I'm just gonna like have a chat with them point of view. But it can also
Yeah.
happen in the organizational context where you're now like an engineering manager focused on a product, and you rely on the expertise of your teammates to like pull it all together, because there's no way that a single person could have that. So I think relying on people is a very important thing. Of course, you still have to learn stuff yourself, and I think the best thing to do is, I don't know. I think that the focus on the problem is still what I would suggest there.
Yeah.
In that, if you're still working on certain problems, you should never say, for example, oh, I'm going to solve this problem with the same tool that I use in undergrad because it's what I learned, right? It's like that's how we did it back then, and it's very fresh.
Yeah.
Like, you might want to think back, and whenever you have a new problem coming onto your plate, you say, how are people solving it today? Like, if you are someone that that never use machine learning, and you were doing, color thresholding for images, and all of a sudden you get a new problem where you're like, hey, the kids nowadays are training neural networks. How do I do that? And then you just start like working on a problem with these new tools. So you shouldn't be afraid to try using new technology and to rely on people that are fresher out of school to help you along with that, because I think it's inevitable that as we get older, then like the next generation will just have like that information so much more readily available.
Yeah, that's also very practical, right? So you at one on one hand you mentioned that you can talk to people who are already studying these things in their curriculum, and your colleagues and other people to stay updated with the information. And at the same time, I think the key idea that you want to put forth is that don't get too hung up on catching up with the information, but rather do your project, and if it is a new research paper that you want to use it for your project, then go ahead, but you can't really probably catch up with everything, right? So it's really impossible. So yeah, I think that's a key takeaway, because yeah, that it's probably the one of the most practical advices one can get, because in this information age, it's easy to get hung up on finishing all the Coursera courses on machine learning and computer vision and everything, and then showcasing your certificate on LinkedIn or whatever. But your point of view is that you should focus on the practical skills, and not get hung up on the theory.
Yeah, and one thing I'll add is just because it can be overwhelming to just like learn a bunch of things. I mean,
Yeah.
learn things as you need them, right? It, if you learn like 5 different things and you don't get to apply them immediately, then you'll probably forget them.
Yeah,
But
makes sense.
if you're working on a project where you have to learn one at a time and then apply it, it'll just stick more. Even if there is that desire to like, yes, I want to know everything now. I understand. It is
Yeah.
a very very common feeling.
Yeah. So do not let your creativity, drive you crazy. This being more practical, because yeah, eventually if you don't use the skill, you'd probably forget it.
Yeah.
So that's the idea. Yeah. Yeah. And about online MOOCs, what is your view on? Are they a good starting point, or for learning, let's say, a field in robotics or computer vision or whatever? Or do you think there's a better approach, or do you think they have certain role, but you still need universities?
Ooh. Okay. I think that MOOCs are great. There are MOOCs of different quality, of course, all throughout there. I think when you're looking for a MOOC, look for one where you have to do a project. In my
Okay.
experience, the Udacity MOOCs are very good in that aspect because
Mhm.
you have to do projects and they are peer reviewed. So someone is actually looking at your work. It's also good because it's open ended and that they just give you a problem and you have to just make things work for yourself. It's not like you have to get exactly this correct answer to 3 decimal points or the autograder will fail you. So MOOCs are great if there are actual projects involved. Um, to that point, we're talking about the whole passive learning as a good first pass. I think, and I've done this before too, even if I'm not like actively taking the MOOC, I will sign up for it and just watch the lecture videos to get myself like a baseline level of knowledge. Again, just to get like the terminology. Um, acknowledging that that is not going to be enough to consider yourself an expert by any means, right? It's just a good starting pass. And if you treat it that way, I think it's honest, it's fair.
Okay. Okay.
Um, as far as replacing university, man, I don't know. There's there are certain things in universities that you're just not gonna yet recreate with MOOCs as the way they are. One of them is actually getting to work with people.
Mm.
MOOCs attempt to do group projects and so on, but generally, it's not the same. Same thing with just the experience of signing up for these like big like student project based competitions like the Robo Cup or the Formula student teams. Like it just that doesn't exist in a MOOC, right? You need a university with resources where you have like a lab space where you
Yeah.
have this like car sitting in the basement that students are breaking every day. like that. You can't replace that yet. Now I do acknowledge that university is, you know, it doesn't have the same level of access as a MOOC. That a lot more people from around the world can get on MOOCs and gain skills that way. And I think that works okay for things like software development, right? It's for the same reason that
Yeah.
you'll find more success in the MOOC space with things like web development or just more general core software development versus things that require you to have hardware experience. Will that change for robotics, where we have more like hardware labs in MOOCs? I've seen that happen in a couple places. Like the Construct, they do the ROS learning things.
Yeah.
They have ways for you to get into like entire virtual machines with simulators, and they have hardware labs. Udacity had this too, where they had a lab at Karlsruhe Institute of Technology, where you could program a KUKA robot arm from your desk to solve a task. But these things are still very rare, and it, I think specifically for the robotics space or the embodied AI, it'll be a long time before MOOCs will give you that hands-on engineering experience.
Yeah, 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 yeah. It's tough when hardware is involved. You have to be in the space of a lab environment or where the robots are actually. Yeah, yeah, yeah. So, can you also comment on your view on the way university curriculums are structured? Do you think they are effective? Because again, like you talk about project-based learning, and in universities you can approach professors and you can do projects and all simultaneously as well. But focusing just on curriculum and the lecture way of learning, what is your view on that?
I am very strongly towards projects. I think less homework, less tests, more projects. I am all
Okay.
for it. You probably still need tests for certain things, especially in like the foundational curriculum. Like you need baseline
Yeah.
math skills, but more hands-on experience is good. I think the universities that have just that produce some of the best engineers are places that have like official
Yeah.
senior design programs. For example, like one of them is Worcester Polytechnic Institute in near the Boston area. They actually have a really really good undergraduate senior design robotics program, and like the engineers that come out of there are top notch. There's other schools that like have a required co-op program where you have to spend like a summer and a semester actually working for a company. You can't just like get by and get your degree only on books.
Hmm.
Uh, they make a better engineer. You know, I'm not going to admit I was the most hands-on person in school, and I still kind of suffer from it. So I do wish more people did more project work, and it was more imposed on at least in engineering programs.
Yeah. If it's
Certainly.
graded and if it's more integrated into the structure, so to
Yeah.
say. Yeah. So also you have a really diverse skill set, and you have been associated with robotics for such a long time. So you can probably give a good view on what are the skills one should have for robotics. Of course, the tools is a different thing, and skills is a different thing. So, what are the skills that one must have to be a good roboticist?
Yeah. So two of them I think we already touched on. One was just the systems thinking. You need to have a baseline level of systems thinking because
Mhm.
in robotics, especially so, you don't have the luxury of saying, "Oh, that's not my area of expertise, therefore let me ignore it." You need to understand a lot of different things because robots are complicated systems. That it is what it is. Um, Another skill that we already talked about was the whole like, don't just learn tools or languages for the sake of it. Don't take a tools focused approach. Take a problem focused approach. I'll leave it at that. But a lot of newcomers will ask things like, "Oh, what's the best programming language to learn? Is it C++? Is it MATLAB? Is it Python?" It really depends on what you want to do. I mean, just I would say, what are you trying to solve, right?
Yeah.
If you're trying to write a piece of software that goes in a microcontroller, then
Hmm.
you're probably going to want to use C. If you're and so on. Although one software tool that I would recommend everyone learn in robotics is ROS. My current boss at Boston Dynamics said this really well, and I want to share it with people. Is that for most robotics companies out there, if you're working on software, even if they're not using ROS, there's going to be something like it. So it's really good to just have that knowledge of like, splitting up your
Yeah.
software into different distributed nodes and serializing messages or serializing data in the form of messages and so on.
A
I think it's worth learning that.
framework of any sort, basically.
Yeah, yeah. So there's that. I mean, my advice is focused on the software side because that's what I've been doing most of my time.
Yeah.
The third one is, and I got this from a book about the Google software engineering process, which is, I forget who writes it, but it's called the Flamingo book. It's a book with a
Oh,
flamingo on it. That software, like programming, does not equal to software engineering. If you're a
okay.
good coder, there's still a lot more in being like an effective software engineer. And I put that as a word of warning for like only doing hacker rank, for example, or like Kaggle or competitive programming. There is a lot more in it. So I would recommend anyone that wants to pursue software engineering to also learn about like the supplemental things in software development, like how to use source control, like Git,
Yeah.
how to unit test your code, continuous integration, using containers, like how to use Docker. All these things are going to make you really powerful and kind of understand how where your code belongs in a bigger system. So even if that is like a completely separate thing from just being a really good programmer or algorithm developer, and both of those things you should have under your belt. Yeah.
Okay. Yeah. And yeah, thanks a lot, first of all, for the really elaborate explanation. And so the focus is, of course, not on tools and on the different states of mind, or the skills that you would have for robotics. And so based on your experience, you have a really good skill level currently. So this is, we talked about what are the skills that one needs. Now my next question is actually, how does a beginner with, he just knows what robotics is, just fundamentals of it, and how does he train himself to reach a level of robotics, just sequentially? Of course, the focus would be on doing more and more projects, but as a beginner, there's also probably a mental barrier, right?
Yeah.
Robotics looks so advanced, and whenever you talk about robotics to someone who's not even in software, they naturally have this inclination that it's a complicated thing. And of course it's a complicated thing, no worries, but that doesn't mean that you can't really learn it, right? So what are the steps that one should take, if you can lay a sort of a rough guideline?
Yeah. Well, the very short answer is just time doing things, right?
Yeah,
Like
yeah, yeah.
like it's impossible to just know
There's no alternative,
everything.
right?
There isn't, but there's also a big aspect of how to use your time, right? For example, let's say for argument's sake, you're a good software engineer, but you don't know a lot about robotics theory, and you want to learn more. You want to be more of like a roboticist than a software engineer.
Mhm.
If you're in a place where like your work or whatever your research duties, whatever it is, they require you to keep doing software engineering in a point that you're not so much like breaking out of your comfort zone and learning, but rather just like constantly like applying your existing skills to solve problems. Like,
Yeah,
maybe you're like becoming a really good software engineer, but you're not getting a chance to exercise the other thing you wanted to learn. You have to like be conscious about it in using your time. In other words, if you find yourself like stuck just doing busy work where you're just like putting out fires and not actually like having any time to do your own exploration and your own learning,
hmm,
then likely you could spend 5 years doing that, and all of a sudden you'll wake up at the end of the 5 years and be like, hey, I still haven't learned anything new.
yeah.
So I do this too. I try to stay conscious of, how have I spent the last month? Have I actually learned something, or have I just been like, you know, like doing busy work, or like what have I learned lately? And if
Mm-hmm.
that seems out of balance, then is there something you can do? Like, can you talk to your advisor about like what you're doing day to day? Like, can it change? If you're in a certain job, can you talk to your manager about that? Or does it mean that it's time to maybe look for another job where you get more of that variety?
Yeah.
So I would say just always be conscious about what you're learning. If you're I don't know, ideally your work day has some time for you to like reflect and think about what you've been learning or like what you want to learn. Because if you're just like stuck in the day to day, then chances are you're like, yeah, your time could be potentially used better if you actually wanted to pick up new skills.
Yeah, so the idea is to be more deliberate about your learning process, right? And not just let it run on autopilot. Yeah, and so moving on to the next question is what would be your advice on choosing a career path? I know like this is something that I asked in the last section, but because of the spontaneous nature of our conversation, I'm mixing stuff here and there. So since this is connected with what we talked about, and your experience has been in exploring diverse career path, of course, related in some way or another with robotics. How does one choose a career path based on one's personality and strengths, and what might be suitable for the person?
Yeah. It's first of all, it's impossible to choose the right career path, right? Like we all choose something and it may or may not be good.
Yeah.
But like you said, there's a lot of decisions that you can make that are informed based on what you said, right? Um, so I think what we were just talking about is one advice that I would give, right? It's if you're in the point of your life where you actually still want to be like breaking out of your comfort zone and learning, definitely place that premium on whatever job or whatever research opportunity you're doing now, right? You should feel fulfilled by the learning that you're doing, or if you're at a point in your life that you don't necessarily want to learn new skills, but rather just like be really productive at your skill set, then look for that in your work, right? Um, you have to kind of ask yourself what is like the favorite part of your day and how can I do more of that, regardless of
Oh.
what that favorite thing is. Um, you know, this is a very blanket advice, but don't be too afraid to take risks as long as you have the ability to do so. That like I think we all live in like fear of failure, but like I think it's worthwhile to try things out. I know even if it doesn't work out, um, you might learn something about yourself in making a decision that didn't pan out right. And I've certainly had my own set of those experiences. And the last thing, and this is one where like I got that a lot because I've had background in like education and marketing, and I have a lot of friends that are hardcore engineers. So you get a lot of like people making fun of you because you're like, yeah, he's a marketing guy. Um, don't necessarily pursue what looks good on paper versus what you enjoy. Like if like let's take machine learning again as another example, right? Like machine learning is super hot right now, like
Yeah.
so many publications, so much money in it. Like maybe a lot of people out there are saying, "Oh, I should be in data science, I should be in machine learning because I'm going to be really successful." Um, if you like it, great. But if you don't and you're doing it just because you feel like it's lucrative, you're probably not going to have a great time necessarily. Maybe if you're more of a mechanical design person, even if it's not as attractive in the social status sphere, that's fine. As long as you can still make a good living out of it, you're
Yeah.
just being content with what you actually like to do versus what other people are saying you should do is pretty important. And yeah, I think that's those are the three things that I would say for that.
Yeah, yeah. And one of the things that you mentioned was what's the favorite part of your day, and what are you doing during that part, and multiply on that, do that more often, and try
Yeah,
to make that portion into a career.
yeah.
So
And tell your supervisor what that is, because chances are they can help you if you communicate that to them. Yeah,
hmm. And being verbal about it, so there's a clear communication about that as well.
yeah,
So just touching on the next question, these are connected. So you talked about your favorite part of the day. How does a typical work day look like for you?
yeah. I mentioned a couple of times that I don't like variety, and that's certainly the case for a typical workday. So I actually have 3 typical workdays
Oh.
that I'd like to oscillate between to keep myself from not going insane doing the same thing over and over. And the way that I broke this down is you basically there are focused planning days first, right? So there are some days where I might not even touch code. I'm just gonna sit back and be like, hey, this is what I need to do. This is how much time I have to do it. Prioritize things. Think about like the general approach as how you would solve a problem. Do a little
Yeah.
bit of investigation, and that goes a long way. Not only does it recharge your brain from just like coding incessantly, but especially from like my marketing days, I've like firsthand learned the value of like planning well and then executing. It actually works,
Okay.
and it's a worthwhile investment. So I'll have days where I just plan. Then I have days where I just code. Like I've come up with a plan. I've driven myself crazy just looking at a Word document, and I really want to program now. So let's just get that done. Open up your code editor. Try things out in simulation. Like really just go deep into a problem. And then there would be the kind of the more focused experimental or robot days, and this is specific to the robotics world, right? Again, I do like programming from home and relying on simulation, just kind of sitting at home drinking my coffee, whatever. Then when it's time to go to the office, I kind of have things ready to go. Like if I want to test things out, like schedule time, schedule focused experiments. Go in, collect the data that you want, talk to people while you're in the office, bounce ideas, and then take that data back and then kind of keep iterating on that. So I know I like cycling through. I guess the answer was like planning, then a lot of coding, and then actually like going out and collecting your data. Or
Yeah.
in the case of other equivalent disciplines, it might be like actually run an experiment. Yeah.
That's a really interesting view on it. I came across this productivity idea that each one of us has this sort of two roles. One is that of a manager and that of a technician. And if we try to play the two roles simultaneously, we are not very productive. So
Yeah.
what I like about your view is that one day is just for management and planning, right? And then you create a plan, and then let's say another day is just for coding, and then doing the things. Maybe you define it in a to-do list, or I don't know how you do it, and then you just stick with it. And then of course with robotics you have to deal with the hardware, so you devote a specific days just for that. So this I think this is a really, it's a simple idea, but it's really, I think, helpful, because otherwise you can make a plan and then you're like, no, that is too difficult to do, and then you don't stick with it, and it's an
Yeah.
endless cycle. So yeah, I think this is a really profound point that you mentioned. um,
Yeah, and it helps you. It also helps your brain like develop the desire to do the next thing. Like
yeah.
if you take a whole day to like not even touch code, and you need to do it, then you'll wake up the next being like, oh my god, like I need to start writing this. Doesn't really happen if you're like doing it 24/7.
Yeah,
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 yeah. Yeah. Oh,
so
that's also like, so because, for example, you like coding, and then if you say that, okay, 1 or 2 days I'm focusing on other things, and then you would be excited to go back
yeah.
to programming. That's cool. Yeah. So moving on to the part where we discuss more about your personal motivations. Of course, the structure today has been more spontaneous, and we talked a little bit about this portion also in between. But based on talking to you so far and also your experiences, so you are someone who is really passionate about robotics, and you have been exploring different areas, and you try to play around and experiment with things, and you still do it as part of your current role. So how does one cultivate passion in a particular field, not necessarily robotics? I mean, whichever field, do you have to cultivate it, or do you have to listen to your instincts and see where your interest lies and then naturally follow it?
Yeah, it's hard, right? Because there are a lot of things in this world that like get you very disillusioned about your work, right? Like sometimes just things are really challenging, right?
Yeah.
Um, I think it's, to me at least, it's very important to like take a step back and think about like what are you working towards, right? So I think having a belief, like wherever you are, like having a belief in the product that you're working on or the thing that you're delivering is very important. Like, I personally am not very. I don't think I could get motivation from being like, you know what? I don't care what kind of thing I'm. I don't care what kind of problem I'm working on. I just care about like doing computer vision, and that's all I care about. I don't work that way.
Okay.
Maybe other people do, right? They'll do the opposite. They'll say, I really, put me in any place, whatever, as long as I'm processing images, I'm good.
Okay.
I'm
Okay.
more about like the end goal. So
Mm.
so I guess my passion comes in from I will, if I'm motivated enough, I will try and learn within reason what it takes to solve that problem, right? And that's where you kind of pick up new skills. Um, so yeah, no, that's kind of how I keep it, right? It's um, it's kind of the next level up for the problem versus tools focused
Yeah.
argument.
Yeah.
That it's not just that you're like solving a problem for your current job, but like
Mm.
your job is itself solving some societal problem, hopefully, and not causing
Okay.
one. And that's good.
Yeah. Yeah.
And in
So I
general, I
can.
mean,
Yeah.
oh, sorry.
Yeah. Please go ahead.
Yeah, the other thing is, I don't know, in my opinion, I think, robots are super exciting in how complex they are. So I'm always just really curious about like how we can make these systems more complicated in a way that we can still like manage them and understand them. Um, so I'm pretty driven by that in general. I don't know. I think having a healthy curiosity for the thing you work on and like actually wanting to understand how things work
Hmm.
is is a good quality to have. And I think a lot of people in our area of science kind of are defined by that, right? Like just a
Yeah. For
curiosity for
sure.
how things work.
Mm.
Um, so hopefully one still, and this goes back to the whole like make sure that you're still learning, right? If your curiosity is still being satisfied in some way in your day to day, then hopefully that kind of keeps your passion alive for the field.
Yeah, yeah. That's a really interesting take on it. Actually, on also, I noticed that you have sort of uh, a framework of thinking, or I don't know if you can call it systems thinking approach, or on the way you operate in your life in general, and not just with career or robotics. So even with selecting a field, you have this. Framework that you focus always on the end goal, and then whether you're selecting a career or doing a project or whatever, you have this end goal in mind, and then you make decisions based on that, rather than just you talked about as long as it's image processing, I'm good with that. So this is your way of operating,
Right.
essentially. Yeah.
Right.
Yeah, that's very profound, and also about curiosity. I think this is anyone who is involved in science. I think curiosity is you're probably driven by curiosity, right? So that's another point. But how do you keep yourself motivated when you're stuck in a problem? Do you remind yourself of the goal, that when it will be finished, it would be cool to see this robot do this particular operation, or how is it with you?
Yes, you sometimes do have to remind yourself of the end goal. The other thing is, one thing that I tell myself a lot when I'm faced with a hard problem is that it is a hard problem. Like if the thing you
Yeah.
were working on were easy, someone else would have already written like a Python package for it, and there would have been a one-line solution for it. So
Mm-hmm.
when one is struggling with something that is challenging, it's either because it hasn't been done before, like in the context of,
Mm-hmm.
say, like if you're doing, like graduate research or working at a company, or if you're earlier on in your life where you're just struggling through solving your homework assignment or something. Like, yes, someone else has solved it, but the point is for you to suffer through it so that you get that understanding and that appreciation.
Mm.
Um, Same thing holds, for example, I keep leaning on machine learning arguments, but I really like the set of machine learning MOOCs by Andrew Ng, because he made
Mm.
you start implementing a neural network from scratch in Python. Like he's like,
Yeah.
write the forward pass of a network, write the backwards pass, or write the gradient. And then once you suffer through that, he's like, okay, that's really nice, but here's Keras, and it's like a one-liner for the entire project you did for a week.
Yeah.
Without having suffered through writing that first thing, you would not gain appreciation, and you would just take for granted all these like APIs that people made. I know
Yeah.
I'm getting back into software because I can't help it, but I think that same thing holds for generally like struggling or like reasoning yourself out of struggling through hard problems. The other thing is, you don't have to be working all the time. I enjoy flexibility in my schedule.
Hmm.
If I am ever stuck in the middle of the day on something and I'm getting nowhere, I will just get up and go for a run, or I will take a nap.
Okay.
Um, you know, Not everyone can do that. I really appreciate flexibility in that. But like sometimes you have to just walk away and like come back to it later. It's it's like ridiculous how useful that is just to walk
Hmm.
away rather than just like tear your hair out because you have to
Yeah, yeah.
get it done now. Um, so helps me. Hopefully it helps others too.
Yeah. Touching on the last point that you talked about the productivity, essentially, if you're stuck in a problem, you would leave it, and when you come back to it, maybe you have a better solution, right? So the some person I talked to mentioned that you can switch between activities. So let's say your job is of programming, so you program the whole day, and then maybe at the end of the day you play music or some
Yeah.
other you maybe you draw or something like that, and a complementary activity that relaxes you. So in a way, this is like a healthy circle, and you don't get stuck with programming. And then you mentioned just walking away and taking a break, going for a run or something.
Yeah.
So, but at the same time, like for example, there's this strict, rigid way also that you can go about it. Is that you have to, if you there's this 10,000 hour rule, right? You probably know about it is if you want to gain mastery in a field, you have to give focused attention to the work for 10,000 number of hours. And
Yeah.
for that, maybe let's say you make a plan that you in 5 years you want to be a master in robotics, computer vision, or whatever, and then you have to spend, let's say, 8 hours every single day, and at some point maybe you're stuck at a problem and you can't spend 8 hours. So essentially, where I'm heading to is there's two approaches. One is the rigid, focused way, and the other is taking another activity and letting it loose sometimes as well. So,
Yeah.
what do you think works best?
Um, okay, so what you're getting to is discipline essentially. That
Yeah, yeah,
sometimes even if you're not like feeling like doing something, you should just be, like very disciplined about it and just keep going
yeah.
anyway.
Exactly. I think you
Um,
put it in a better way.
yeah,
Yeah,
you
yeah,
and that works. I think establishing that routine, like, sometimes you just don't feel like doing something and because it's like I don't have an option. This is just, I am scheduled to do this now. I'm it,
yeah.
it, it it's gonna happen. Uh, that works really well, and I think I personally don't work that way myself, which is why I'm saying the complete opposite. But I think
Okay.
there's a lot of value to that. I think the thing that I'll say is, even if you are more of like a spontaneous person, like how I enjoy my schedule, you have to make sure that you still put in a fair amount of work, right? If I decide to step out for 2 hours in the middle of the day to go for a run, then am I putting in those 2 hours at another time, right?
Okay.
Like so I enjoy things like that more. Like, sometimes I'll just say, oh, I don't really feel like working this morning, but I might like stay up late that night to work. So you need to keep in mind, are you devoting a fair amount of time,
Hmm.
regardless of like when or how you schedule it? That's different. But that I guess what I'm trying to say is, one thing is to just like reduce the amount of time that you spend, and the other one is to reshuffle it to
Okay.
align with when you feel productive yourself,
Hmm.
while still investing the same 10,000 hours. And I
Yeah.
subscribe to the latter. I think, you cannot replace effort and time that you put into something. Uh, yeah, I just kind of tune it more to like when I'm in a better mood to work. That's it.
Ah, yeah,
Yeah.
yeah, yeah. So a more flexible approach, but still working the same number of hours. Let's say 8 hours, you'd still be working 8 hours, but maybe
Exactly.
2 hours here and 3 hours
Exactly.
there and something like that.
Yeah.
Okay, yeah, yeah. And touching on to this, I want to also know about what the most challenging phase of your career has been so far? Like,
Yeah.
take into account the whole journey from beginning till now.
Yeah. I think the most challenging thing. So I mentioned at some point that I took a short break from MathWorks between two of my jobs there, and that was like the first time that my itch to kind of get back into the engineering manifested itself. Where I ended up going to a company that where I was going to be a software engineer, or I was a software engineer, working on autonomous systems, and it's something where like things happened where where I ended up was not really a good fit for what I wanted to do. I kind of wanted to get into the like robotics programming, like actually creating autonomous behaviors type of work. But what ended up happening is because I had all this experience with Simulink and simulation, uh, I was kind of put on to work on things that required that skill set. And
Yeah.
I felt like, it's not what I wanted to do. I wasn't terribly happy about the fact that I was just doing that instead of doing, more like the robotics programming I wanted to do. And I thought that maybe, there was something wrong. Like maybe it's like I'm not good enough to do algorithms, so I'm doomed to just do simulation stuff. Um, you know, but even if I'm doing simulation, why am I not happy about it? Am I just not good at engineering? Should I have stayed with education? So I like kept compounding into this personal crisis where I thought to myself, maybe I'm just not suited for engineering. Like, what do I do? Um, and that was, yeah, I think that was a really challenging moment because it really made me doubt my skills in a way that wasn't really reasonable. And thankfully, I was able to come back to MathWorks for a different job where I was back in education, but I gained enough skills to try again in pursuing like a robotics software engineer role later on in life. That would have been when I got to MIT. And I was super apprehensive about that because it's like I already messed up once. Is this going to be the same thing again where I'm going to go there and be like, oh, I should have stayed in education because you don't
Yeah.
get another shot. But it actually worked out really well. So I think it was really hard to like make that second jump again, given the fact that the first time didn't go according to plan, and it was really, really tough for me. But I don't know. I guess in my case, it had a good ending. I don't regret having gone somewhere I didn't enjoy because I learned about myself.
Yeah.
So yeah, I think it goes back to the advice I gave about taking risks within reason. If you can, like, you might run into a situation where you jump into something and you're like, hey, this really doesn't work for me. You know, can I fix it? If not, then just step back and think again. What is it that I like doing? Uh, what skills do I need to make sure that if I try again in the future, I will be more informed. I will have the right level of skills, and so on. So it's not
Yeah.
an easy thing to do. Like starting a new job in general is a bit of a gamble.
Yeah.
But the more, not that I'm telling everyone to just job hop all the time, but the more you try this, the more you learn about like, what you like and what you don't like.
Yeah. So again, about taking the risks to explore different areas and see where your interests align. Uh,
Yeah.
Basically, yeah.
Yeah, and if things didn't work out, then they didn't. If you have a good reason for it, then you can explain it.
Yeah.
Yeah.
And also, you spent some time when you took a break. You spent some time contemplating about what you really want and how it aligns with your career. So how did you actually like accelerated your journey of contemplation and made the next leap at some point?
Ooh. Um, I don't know if it was accelerated. To be honest, it was more like, yeah, I guess I thought about the kind of the nature of two different roles, right? In education, when you're making materials, then you're doing something that is just simple enough that somebody could grasp. Like, you're teaching someone how to write code. You're going to write something that is just simple enough that people can kind of get how complex it could be, but you're not doing something super complex. You're not doing a lot of design iterations. Um, and I, and for me, what I found is that in the more education space or marketing space, you're really like creating a proof of concept for somebody else and then letting them do the design versus being on the other end where you're like you might spend a lot more time working on the same problem over and over and like really chewing on that design. And those are two very different things that different people gravitate towards, right?
Yeah.
So I thought a lot about that, like, what do I prefer? And in my case, I really prefer like standing up something and then letting someone else go do the work. So a lot of what I ended up doing later on kind of took that flavor, right? In the making of educational videos, in working on the kind of academic demos where also things are pretty scoped down. And it's only now that I feel like I've gained enough skills to be comfortable again with jumping back into design. And it's been good. And I feel because I have more experience now, I'm not super bogged down by both the fact that I didn't know how to program and that I didn't know how to design. Now at least there's like, you know, the the amount of new things to learn is a little bit reduced, and I'm having a good time, kind of
Yeah,
focused on
yeah.
being more like a better designer.
So in essence, the whole journey you can also view it as a learning journey, right? Even I'm including your MIT experience, your MathWorks experience, and so on. All of these, gave you the skill set that you're now using as a robotic software engineer. So you could view it all of it as like your education in a sense, even though it was work.
Yeah, absolutely. And I mentioned earlier that I do find that really important, right? Like, are
Yeah.
you actually learning something on the job, or are you just
Mm.
devoting your time to someone else?
Yeah.
With most jobs you are, but if you're not getting something back from it as well for your own benefit, then
Yeah.
it's a one-sided transaction. It shouldn't be that way.
Yeah, yeah,
Yeah.
makes sense. So you've worked on service robots at MIT, and now you're working on logistics in the logistics domain, and before that you worked on other aspects of robotics and also education. So overall, how do you see yourself impacting other people, or yeah, just in general, how do you want to impact others by means of your work?
Well, I think the impact that I find the most rewarding still remains the educational aspect.
Okay.
I even though I'm currently an engineering, a software engineer, I still want to have a hand in educating. One thing that for example, I've expressed a lot, even now, is kind of helping out with things like outreach or getting potential new hires up to speed with like, oh my gosh, how do I navigate this giant code base? So
Yeah.
I think in as I like progress in my career in general, I think I do want to have more of like a mentorship tilt to what I do, in that I think I am better served, and I personally like more getting someone else unstuck than getting myself unstuck. If that makes any sense, right?
Yeah,
Um,
yeah,
so just being able to gather the skills to actually be useful at helping a group of engineers design systems for Boston Dynamics, that would be great, or for wherever I am, right? Being someone that people rely on when they think of, hey, is there an expert in robot behavior that has like proven stuff on real world systems, and they think if someone ever thinks of me, then I'll know I've made it. Of course, there's a lot more years before that's the case, but um, that's kind of the impact that I would like to have. It's to help
that's
others
really,
like get past the how overwhelming robotics is in the way you put it.
yeah,
Yeah.
getting past the barrier.
Yeah.
Yeah, yeah, that's really amazing. That's an awesome, view. And finally, the final question that I want to ask you is about book recommendations. Do you have some book recommendations that shaped the way you think? It could be technical or it could be just general.
Yeah. I do. my reading lists are very strange. So I picked three books that are kind of representative of the whole spectrum.
Okay.
Um, One book that I really like. This is more for the AI folks. It's
Mm-hmm.
called The Alignment Problem by Brian Christian.
Okay.
This book, I don't know, it's like a super accessible intro to AI. Even if you're not a researcher in AI, maybe there's a lot of like repeated stuff. But what I really like about this book is that it balances a lot of things that I like about AI writing, in that it has a lot of historical context. So they talk about like, the origins of reinforcement learning, for example, or like
Mm.
how the SciFar initiative started. So there's a lot of just like history and like how the researchers began thinking about how people think and how that became what we call AI today.
Mm-hmm.
Additionally to that, it talks a lot about the ethical implications of AI, which is of course important, but it doesn't do it in a way that, there's a lot of books out there that are just like 100% alarmist about, like AI is terrible at everything. We're all gonna die. This book really strikes a balance. It speaks about it from a historical view. It
Mm.
speaks about it with some optimism about what the future of machine learning can hold, and it also has a lot of cautions about ways that black box systems that use data can be wildly misused. So that's a great book. Um, Thinking Fast and Slow by Daniel Kahneman. I'm sure it's a book that a lot of people recommend, but it's a great book about just like, how we think,
Mm.
particularly like our conscious versus unconscious kind of part of the brain.
Mm.
Um, what I like about this book, besides that it's just super interesting, is that it's really fun because there's a lot of experimental results
Yeah.
that are shared to back up the findings, and there's a lot of like mathematical puzzles for you to work out while you read the book. So like you're basically like, I remember when I was reading it, I had a piece of paper where I was like doing like all the probability stuff. I enjoyed it. I gave the book to my dad, and he did not like. He was like, "Why do I have to do math? I'm reading a book." But if that's for you,
Okay.
do
Yeah.
it.
Yeah. Mm.
Um, and the third set of books, uh, you know, it's fiction. It's the Remembrance of Earth's Past trilogy, or also known as the Three Body Problem books by
Oh.
Cixin Liu. Um, yeah, it's a sci-fi book about basically aliens. But what I really like about this is going back to the AI world again. I think when humans imagine stuff, I think about this a lot. Like when we imagine things, we are always interpolating from things that we have seen in the past. And you can think of like the same thing for a neural network where you're just always looking at things within distribution of training data.
Mm-hmm.
This book is like the author has so much imagination that I truly believe he has like out of distribution thinking, because the things that he came up with and like the scale of like time basically that he applies in the books, like as far as like explaining the universe in like ways that really mess with your head. Like this is a special person that wrote the book, and I would highly recommend it. Um, so
What's
those
the name of the book again?
the first book in the trilogy is called The Three Body Problem.
The three body problem. Yeah.
Yeah. The trilogy is called Remembrance of Earth's Past. So it's three
Okay.
books by the same author. But yeah, they're super good. I recommend people read them if they want their brains to melt a little bit. Would recommend. So yeah, I,
Okay.
I mean for each of these three books, there's lots of other books similar that I like. So if
Mm.
anyone wants to know more, you can always reach out. But that's a sample of what I like.
So these are the three categories. The last one is actually about the where you're looking for more creative ideas and like more imaginative sort of domain. And the first one is about so the second one is about the how the mind works, and the first one is more about engineering and AI in general.
Yeah, and specifically about the role of AI in society, which is something that
Okay.
we all have to
Okay.
think a lot more about as we
Yeah. Okay.
as we do things. There's a lot of great books in that vein for sure.
Mm.
So
Mhm.
yeah.
Okay, perfect. Then, with this, I'd like to thank you for the amazing discussion that we had. We talked a lot about your overall journey and about in detail about your professional experiences and how all of these experiences shaped you. You gave a lot of advice on how to start learning robotics, but also how to think and how to make decisions and stuff like that, and what inspires you. And in the end, you also gave some advice on how to choose the right career path, and how to what kind of books you read, and all these areas. So it was really fascinating discussion with you. And maybe we'll do another discussion in the future.
Yeah, this is a
Yeah.
great discussion. Thank you for having me on. Hopefully, some of the many things we talked about are relevant to those listening. And I'm always happy to chat more about any of these things. Yeah.
Yeah. Thanks a lot.
Hey guys, I really hope that you enjoyed this particular conversation and it helped you in some way, shape, or form. If it did, make sure to hit the subscribe button and the notification icon or the bell icon so that you can get notified on time whenever the next part is out. Also, it would be really great if you could give me your feedback in the comments below. That would really help me improve. I'm uploading small clips of the long podcasts on a regular basis on platforms like LinkedIn, Facebook, and Instagram. So make sure to follow me on these platforms if you're someone who cannot take out time for the long episodes. The podcasts are also available on all major podcast platforms, including Spotify and Google Podcasts.